Hi everybody, let's do 7th grade DD.1. So we'll go to Learning here, scroll down to 7th grade, and then down to DD.1, which is the probability of simple events. When we're talking about simple events, we just mean that we're going to do one thing. Later, when we get to compound events, then we're going to do more than one thing. So one thing might happen, and then another thing will happen, and another thing. But now it's just one thing. Before we get started with these problems, I'm going to read through a little bit of the reference page. So probability is on page 11 in the reference pages. So let's scroll down here. It was one page off. Okay. All right, here is, you can see at the top here that is page 11. And what do I need to know? So in here in the probability section, hopefully you watched the other video that I posted, which explained that when we talk about probability, we're talking about how likely something is to happen. Is it probably going to happen? Is it probably not going to happen? Is it definitely going to happen? So we put all those probabilities are measured on a scale from 0 to 1, or as percentages 0% to 100%. A probability of 0 means that something will definitely not happen. A probability of 1 or 100% means that it definitely will happen. It's not a question, it's definitely going to happen. A probability of 0.5, which as a percent would be 50%, means that it is just as likely to happen as it is not to happen. So think of flipping a coin. The odds that you get, the probability that you get a heads is 50%. You might get a heads, you might get a tails with equal likelihood. A probability that's somewhere between 0 and 0.5, or between 0% and 50%, not including 0% or 50%, just somewhere in between, means that the event probably won't happen, but it still might. And a probability between 0.5 and 1, or between 50% and 100%, meaning something like 61% or 87% or 99%. That means that it probably will happen, but it still might not. Okay, now that we know what these probabilities mean, how do we find the probabilities in the first place, which is what we're going to have to do for this exercise? Well, to find a simple probability, you need to remember this fraction here, good over total. That means we take the number of outcomes that we consider to be good outcomes, and we divide that, or if we're writing it as a fraction, then we just put it over the total number of outcomes, meaning every possible thing that could happen. So good over total there. And, well, let me just go to IXL and do some questions here. Maybe I'll read through the next section of that a little later, if I remember. Okay, so here's my first question from 7th grade DD1. Of the 10 people attending a seminar, 2 have black hair. What is the probability that a randomly selected person will have black hair? Okay, so let's see if we understand what the question is really talking about here. Let's say that we have 10 people. There's 1, 2, Okay, those are my 10 people. And what did the question say? It said 2 of them have black hair. All right, so let's say this person and this person over here have black hair, and other people have, this guy's got red hair over here, red hair over there. I don't know, just having fun. What sort of wacky hairstyles could I give people? That guy's got a mohawk. This guy's maybe got a Homer Simpson kind of look. And let's do some more colors here. 1, 2. Okay, 3 people have purple hair. Okay, so out of the 10 people, 2 of them have black hair. And we're going to select somebody randomly from these 10 people. So we're going to close our eyes and then just pick somebody. What is the probability that that person will have black hair? So what we need to do is we need to remember our fraction for finding a probability, good over total. So what do we consider to be good? In this problem, we consider black hair to be good. There are 2 people with black hair out of a total of 10 people. So that is our probability, 2 over 10. For this exercise, IXL does not require that you reduce that fraction. Sometimes they do. You could reduce that to 1 over 5. It might ask you for some questions to write it usually as a percentage. As a decimal, if we do 2 divided by 10, we'll get 0.2. And then we just move the decimal point 2 spaces to the right to get a percent if it asks for a percent, and that would be 20%. So remember, the highest probability is 100%. The lowest probability is 0%. What does a probability of 20% mean? It means, let's go back to the reference pages here, a probability of 0.2, that would be between 0 and 0.5. That means that it probably won't happen, but it might. And if I think about this situation, that's true. If I close my eyes and I just randomly pick one of these people, I'm probably not going to get somebody with black hair because there aren't many people with black hair, but I might. I might pick somebody with black hair. Okay, so that's what the probability means. And let's just put it in here. 2 over 10, submit. Okay, we got it. A university class has 16 students enrolled, 6 of whom are seniors. What is the probability that a randomly chosen student will be a senior? Again, what do we consider good here? Seniors are good, not sophomores, not freshmen, not juniors. Seniors are good in this problem. So we put the good, which is 6, over the total, which is 16, and that is our probability. That would also be, so if I wanted to do it as a percent, we could do 6 divided by 16, which would be 0.375. As a percent, that would be 37.5%. So again, it's less than 50%, meaning if I randomly pick somebody, that person probably will not be a senior, but they might. They might. All right, I'm going to skip ahead, which I can do as a teacher, to the next type of question that you're going to see in this exercise. Okay, you roll a 6-sided die. What is the probability of that die coming up as an even number? All right, so what does that mean? When it says P and then in parentheses even, that means the probability of getting an even number. So if I roll a die, what outcomes could I get? I could get a 1, a 2, a 3, a 4, a 5, or a 6. Now, how many of those numbers are even numbers, meaning they're divisible by 2? That would be 2 is an even number, 4 is an even number, and 6 is an even number. So if I do my fraction here for finding a probability, good over total, then I have 3 good outcomes, 2, 4, and 6, out of a total of 6 outcomes. The 6 total outcomes are just 1, 2, 3, 4, 5, or 6. So there's my probability, 3 over 6. I do not see that as an answer choice here, which means that I should reduce this. I can divide the numerator and denominator by 3. I get 1 over 2. If I wanted to do it as a decimal or as a percent, that would be 0.5, which is 50%. If you don't know that off the top of your head, you could just do 1 divided by 2 equals 0.5. Okay, so there's my probability. Whoop, I did not mean to do that. Okay, there is my probability, 1 out of 2. What does that mean, a probability of 50%? Again, it means that the event is just as likely to happen as it is not to happen. Okay, it's right in the middle. So if I roll a die, the probability that I get an even number is exactly the same as the probability of getting a number which is not even, of getting an odd number. Okay, so let's just put that in. You saw over here, I'm listening to some rain sounds while I do this in my headphones. Hopefully you can't hear that. Okay, so 1 over 2. There we go. Okay, you pick a card at random. What is the probability of that card showing a prime number? Remember, prime numbers are numbers that are divisible only by themselves and 1. So they're not divisible by any other numbers. So I have a 5, a 6, a 7, and an 8. And let's do our good over total here. Okay, how many of those numbers are prime numbers? Because those are the good numbers for this question. 5 is a prime number. You can only divide it by 5 or 1. You could divide it by other numbers also, of course, but you would get a decimal answer. 6 is not a prime number because we can divide it by 2 and 3. 7 is a prime number. It's only divisible by itself and 1. 8 is not a prime number because I can divide 8 by 2 or 4 by other numbers. So 8 is not a prime number. So I have 2 good numbers over 4 total numbers. 1, 2, 3, 4. And, we could reduce that also. I could divide both of these by 2 to get 1 over 2. This, again, is equal to 0.5 or 50%. Okay, but it's okay, actually, if we just put this in as 2 over 4. There we go. Let's try another one. Oh, I'm going to roll here. You spin the spinner once. What is the probability of this spinner landing on a number that is less than 5? Okay. Well, what are our options here? The spinner might land on 2, it might land on 3, it might land on 4, and it might land on 5, right? 2, 3, 4, or 5. What's the probability that I get a number which is less than 5? Okay, well, how many numbers are less than 5? This number, 2, is less than 5. 3 is less than 5. 4 is less than 5. 5 is not less than 5. 5 is equal to 5. So we have 1, 2, 3 good numbers out of a total of 1, 2, 3, 4 numbers. And 3 over 4 as a decimal is 0.75, which as a percent is 75%. Am I still recording here? I hope I'm still recording, not just talking to myself. Yes, I am. Okay. All right. If you don't know off the top of your head that 3/4 is equal to 0.75, just type it into a calculator, or you could do the long division by hand. 3 divided by 4 equals 0.75. Okay, so 75%. All right. Okay, you flip a coin. What is the probability of getting a tails? All right. Okay, so what are the outcomes if we flip a coin? If I flip a coin, I might get a heads and I might get a tails. So if I want to find the probability of getting tails, well, how many good outcomes for me? How many of those outcomes are good for us? Just this one. We only want a tails. So that's only one good outcome out of 1, 2 total outcomes. Okay. Now this time it's asking us for a percentage. So again, 1 divided by 2 is 0.5, which is 50. That looked terrible. 50%. Okay, so let's put that in. Well done. Okay, so here we have a problem which is, I know it's going to throw a lot of people off, so let's just go through it carefully. Students in the high school choir sing one of 4 voice parts. Altos, soprano. That looks like 3 voice parts. Altos, sopranos, and tenors, but that's okay. It doesn't really matter. What is the probability that a randomly selected singer will be a tenor? Okay, so once again, we have to do our good over total. Okay, let me tell you something which is wrong. I know that a lot of people are going to do this. A lot of people are going to say, well, we have our altos and we have our sopranos and we have our tenors. And who do we like? We like the tenors for this problem. We want to know the probability of randomly selecting a tenor here. So if we put all these people in a group, all the altos, sopranos, and tenors, what's the probability that we randomly pick a tenor? Well, a lot of people are going to think that that should be that we have one good outcome over 3 total outcomes, but that is incorrect. Why is that incorrect? Because I do not have the same number of altos, sopranos, and tenors. I have many more sopranos, for example, than altos. There are 27 sopranos. There are only 3 altos. So I have a much better chance of randomly selecting a soprano from this group than randomly selecting an alto. So I need a better way of working out this good over total fraction than simply saying that it's 1 over 3. So how are we going to do this? First, we're going to erase this, and you have to give me a second so that I can figure out how to do that. I think I did it before. I can't remember what I did. Oh, now I remember. Okay. Now go back. All right. So there were 3 altos, there were 27 sopranos, and there were 10 tenors. So our good number is just going to be 10 for the tenors. 10 for tenors, that makes sense. And our total number is going to be the total of these numbers, so we have to add them up. 3 plus 27, we're going to add all of these up in the denominator, plus 10. So we're also going to include the tenors. So 3 plus 27 is 30, and 30 plus 10 is 40. So we get 10 over 40, which we can reduce if we divide both of these by 10. We can reduce that to 1 over 4. It's not asking us to do that, but it'll accept both answers. So I have a 1 out of 4 chance of picking a tenor. All right. We did questions like this. The probability of picking a 6 would be 1 out of 3. Is it going to give me any different types of questions? Okay, let's move on to the next section. The challenge zone. Right, a bag of trail mix contains 825 pieces, including 3... this is a tricky one. A bag of trail... Oh, actually, well, not really. A bag of trail mix contains 825 pieces, including 335 peanuts. What is the probability that a random piece from the trail mix will be a peanut? All right, so again, we're going to do good over total. Okay, what do we like in this bag of trail mix? We like the peanuts. Okay, the peanuts are good. So we have 335 peanuts, so that's 335 good things from the trail mix bag. Now for the total, now this is why I said before that it was a little bit tricky, because for the total here, you have to decide, should you be adding these numbers up? Should I add 825 and 335 to find the total? Remember in the last question, we did add up the numbers. In this question, we're not going to. Why are we not going to add the numbers? Because it says here, including 335 peanuts. In other words, this number 335 is already included in this number 825. So this number and this number are not separate. The 335 is already in here. It has already been counted as part of the 825 pieces of nuts that were in the bag of trail mix. Okay, so we don't have to add everything up. So that means our total is simply the 825 pieces of trail mix. So watch out for that word including, which is telling you that this number is already a part of this number. So you don't have to add these two things together. So that would be just 335 over 825. There we go. Okay, the probability of getting tails is a half. Any different types of questions here? Yes, okay, so this is an interesting one. Downtown Donuts has 30 maple donuts. I hope I'm still recording here and not just talking to myself. I am. Okay. Downtown Donuts has 30 maple donuts and 34 other donuts for sale. What is the probability that a randomly selected donut will be a maple donut. Okay, so once again, let's do good over, good over total. How did I do it before? Does anyone remember? Can you tell me? I don't remember what I did before. How did I... there, what did I do? Okay. Right. Okay. So what kind of donuts do we like? Well, I like jelly donuts, but apparently IXL likes maple donuts. So we're going to put the maple donuts in the numerator here. We have 30 maple donuts. And for the total, what's the total number of donuts? So again, you have to be careful. Sometimes we need to add these numbers up, and sometimes we don't. How do you know whether you should add them up or not? Well, I'm sorry to tell you, you have to actually read the question. So this says that Downtown Donuts has 30 maple donuts and 34 other donuts for sale. So is this 30, are the 30 maple donuts already included in this number of donuts, in the 34 donuts? No, it is not. Okay, these 34 donuts are completely different types of donuts. They're jelly donuts or chocolate donuts or sprinkle donuts, whatever. So the 30 is not included in the 34. That means we need to add up the 30 and the 34 here in the denominator for the total. So we get 30 over 64. That's going to be our probability. And that would be a little bit less than half. So, in other words, if I do, it's not asking me to do this, but I'll do it anyway. If I do 30 divided by 64, I get about 47%. If I round, that'll be about 47%, which again is a little bit less than 50%, meaning if I just randomly pick a donut, who does that? Do you ever go to the donut store and randomly pick a donut? No. You know what you want, right? Well, anyway, if you're crazy and you go to the donut store and you randomly pick a donut, then this is telling us we will probably not get the donut that we want because the odds of getting that donut is a little bit less than 50%. So we probably won't get the donut that we want, but we might. So a better idea is to just order what we want, right? So 30 over 64. All right. Again, so yeah, this is, again, it's the same kind of problem. For this kind of a problem, the probability of getting chicken nuggets, again, it would be 14 chicken nuggets in the numerator, 14 in the numerator, and you would add everything up in the denominator. I'll just do this one last question, and I think I've covered all the types of questions that you're going to see. So our good over total here is going to be, again, this is for the chicken nuggets. So we have 14 chicken nuggets out of a total of 7 plus 4 is 11. Whoops, yeah. Plus 4 is 11. Plus 14 is 25. Plus 19 is 44, right? 14 over 44. Okay. There we go. All right, so we've done questions like this. This would be 1 out of 3. Okay. Have a great night.